Hello students, in my last video we have learned a very important topic from surface chemistry, that is the discovery of electron. Yes, today I am going to discuss next very important topic, that is discovery of protons. The discovery of anode rays leads to the discovery of protons. Yes, a famous scientist, Goldstein, constructed a special tube known as canal ray tube. This glass tube constructed by Goldstein is known as canal ray tube. Yes, this tube consists of two chambers. Yes, this tube consists of two chambers. These two chambers are separated by a perforated metallic disc. This perforated metallic disc known as cathode. Okay, the perforated means what? Yes, the substance having very small pores. Okay, this metallic disc, this cathode having very small pores, hence this cathode is called perforated cathode. Yes, then the space between this cathode and anode, okay, is filled with a small quantity of gas. Okay, then the cathode and anode supplied by very high voltage. Okay, then when we apply very high voltage cathode and anode under low pressure, we know the cathode emits cathode rays in the form of electrons. That means the cathode emits electrons. Okay, then the electrons emitted by the cathode may hit with the gaseous atom. These fast moving electrons emitted by the cathode may collide with the gaseous atom. Okay, then yes, then these collisions knock out the electrons from the gaseous atom. When the gaseous atom loses electron, the gaseous atom become positively charged species. Okay, already studied. The cathode rays can ionize gases. When the electrons emitted by the cathode collide with the gaseous atom, these electrons knock out the electrons from the outermost shell of the gaseous atom. Then the gaseous atom changed to positively charged ions. Yes, then these positively charged particles move towards cathode and pass through the holes in cathode, okay, and cathode, and forms, okay, a beam of positively charged particles on the back side of the cathode. Okay, back side of the cathode, okay, a beam of positively charged particles are formed. Yes, this beam of positively charged particles pass through the holes or canal in the cathode. Hence these rays are also called canal rays since these positively charged particles move through the holes or canals in the cathode. Hence, these rays are also called canal rays. Okay, yes, these anode rays are also called canal rays. Anyway, we can say that these canal rays or anode rays consist of positively charged particles. Okay, then yes, what are the main properties of anode rays? First property, okay, just like cathode rays, anode rays also travel in straight lines. Okay, anode rays travel in straight lines. They travel in straight lines. Okay, number 2, anode rays also consist of material particles. They consist of material particles. Okay, then the next property, yes, please listen. When electric field is applied, when positive field and negative field is applied, we can observe that these anode rays get deflected towards the negative field. Hence, we can say that anode rays consist of positively charged particles. Number 3, they consist of positively charged particles. Then number 4, yes, they get deflected when electric and magnetic fields are applied. That is the next property. They get deflected when electric and magnetic fields are applied. When electric and magnetic fields are applied, they get deflected when electric and magnetic fields are applied. Then, what are the main differences between cathode rays and anode rays? First difference, cathode rays consist of negatively charged particles, but anode rays consist of positively charged particles. Then what about the second difference? Yes, if you take any gas in the discharge tube, the particles of cathode rays are electrons. Okay, so the charge to mass ratio, the E by M ratio of cathode rays is always same, that is 1.76 into 10 raised to 8 coulomb per gram. Okay, 1.76 into 10 raised to 8 coulomb per gram is the E by M ratio of the particles of cathode rays. That means E by M ratio, charge to mass ratio of particles of cathode rays, okay, is independent of nature of gas taken in the discharge tube. But in the case of anode rays, E by M ratio of the particles depends on nature of gas taken in the discharge tube. For example, if helium gas is taken in the discharge tube, what will you observe? Please listen. Helium, its atomic number is 2. Okay, hence helium atom, the nucleus of helium consists of 2 protons, its mass number is 4, it also consists of 2 neutrons, and the K shell consists of 2 electrons. Okay, Yes, then when we apply high voltage, cathode emits electron. These electrons knock out the electrons of the helium atom. When the helium atom loses electrons, when the helium atom loses two electron, it becomes He2 plus. This He2 plus particles has particular E by M ratio, charge to mass ratio. Then, yes, when we take hydrogen gas in the discharge tube, yes, hydrogen, the atomic number is 1. The ordinary hydrogen has only one proton in the nucleus and one electron present in the K shell. Okay, when the electrons are emitted by the cathode, ejected by the cathode, knock out the one electron of hydrogen atom. The hydrogen is changed into H plus. H plus particle has a particular E by M ratio. Yes. Okay. Anyway, we have said that the E by M ratio of He2 plus is different from E by M ratio of H plus. H plus has only one proton, but He2 plus has two proton and two neutron. That means charge to mass ratio of particles of anode rays depends on nature of gas taken in the discharge tube. Okay. Then when we take hydrogen gas in the discharge tube, the E by M ratio is found maximum. The reason is that hydrogen is the lightest element. Okay, that means its mass is very, very less. Okay, when M decreases, actually E by M increases. Okay, then if you take hydrogen gas in the discharge tube, the E by M ratio is found maximum, and that particle is nothing but a proton. H plus is just similar to a proton. Means the very important point, if hydrogen gas is taken in the discharge tube, the positively charged particles of anode rays are proton. Proton is just similar to H plus ion. Yes. Then what about the charge to mass ratio of protons? Please listen. Charge to mass ratio of proton. E by M ratio. E by M ratio of proton is found to be 9.58 into 10 raised to 7 coulomb per kilogram. Okay, then the charge of proton E 1.602 into 10 raised to minus 19 coulomb. That means the magnitude of charge of electron is equal to that of proton. Okay, only, yes, they differ in the sign. That means if a proton carries 1 unit positive charge, an electron carries 1 unit negative charge. Then mass of proton. Mass of proton is 1.675 into 10 raised to minus 27 kilogram. Then what is meant by proton? Proton is a fundamental particle of an atom which carries 1 unit positive charge. The magnitude of the charge is 1.602 into 10 raised to minus 19 coulomb, and its mass is almost equal to that of hydrogen atom. That is 1.675 into 10 raised to minus 27 kilogram. Okay students, in my next video I will discuss about two important atom models, that is Thomson's atom model and Rutherford's atom model. Goodbye, study well.